Hey, Steph, have you seen the array data analysis software in SimCenter Test Lab?
I have not seen that.
Yeah, so this is a new software interface we have for doing some additional processing and analyzing of any data that you've taken with our sound camera. It's in Test Lab, and it gives you some of the features for advanced processing that the sound camera software doesn't have,
Really
including
cool.
Yeah, it has some of the low frequency processing that you may need. And one of the main benefits, if you remember, is with the HD acoustic camera software, it just used a single still image. So whenever you take data using the sound camera software, it acquires data in a video format and displays the source localization on a video as opposed to a still frame. The great thing about that is that you can always see if there's a part moving. You can see where that localization is at that moment in time with that part in whatever position it may be at that given time. One of the drawbacks with the HD acoustic camera is it would always just default to the first frame of that video acquisition. But with our array data analysis software, what I'll show you is that it'll go to the correct still frame in that moment in time to give you a better insight into the visualization. Does that make sense?
Yeah. Is this tokenable?
This is tokenable. So yeah, so if you have tokens, depending on the amount you have, you'll have access to this software as well.
Cool. I'm excited to see it.
Yeah, so let's open up a file here. And it's just a general file of one of our coworkers using his phone to generate a tone. And we're gonna see if we can follow that tone as we go. So if I kind of take you through the quadrants of display here, we have the time display of a given microphone, and I can pick a different microphone here if I want. You can see there's a list of all the microphones on the sound camera. In this case, our sound camera was set up with 81 microphones, so it had the short arm extensions on that. But I'm going to stick with microphone 1 for our time data. And then we have an FFT, or the frequency domain of that given microphone. And again, I can pick a different microphone over here on the right if I want to. And then down in the bottom left, we have a color map that shows the frequency and time using color to give an amplitude of the frequency over time. And I can pick the time and frequency that I want to determine a noise event, and then I get the source localization. So right now we have 3000 hertz highlighted at this moment in time, and you can see where this phone is relative to the noise. So if we go to a different moment in time, going back to what I said here at the beginning, then that phone should be moved. And let's see if the red dot of the noise lines up to that. So if I hit run, it's going to go through and compute that, extract the right image.
Hey, look at that.
How about that? Now you see the phone in a different position, highlighting where that noise is. So it's kind of a cool feature. And you can see even there's some other tones out here. They're probably harmonics of the tone that's being played through the phone, but we can switch that and just confirm whether or not it's the phone by moving this cursor. And we'll even make it a little more difficult on ourselves by moving the time cursors as well. And if I hit run, we'll get an updated display and see where everything is. Okay. So there we see that he moved the phone and that noise image is still following the phone. Now, another nice feature with the array data analysis software is everything that I have calculated is kept up here at the top. So I don't have to go back and recalculate anything that I've done previously. I can click on any of these results up here, highlight them, and it updates that image based on that previous processing.
Wow, that's cool.
Yeah, so I don't have to do anything twice. So that's some fun features to start with. I was gonna open up some other stuff to show you some other features that are available in this software interface that you won't get in the base sound camera software package. So let's open up another test where I brewed some coffee this morning.
Love it.
So we'll go through some different runs, but I want to show some features here where you can see I've got a coffee grinder, and a tea kettle here. And so this is the first run. And so I'm grinding some coffee beans. And you can see there's a lot of frequency content displayed here throughout the process. And if I pick a different moment in time, that FFT will process based on that selected time segment. And I can go to different peaks here. So if I go up to, say, this one, somewhere between 2000 and 3000 Hertz, and I hit run, we'll get a acoustic hotspot, so to speak, on where that noise is coming from. And you can see it's at the bottom of the coffee grinder there. And if I move,
Love using Siemens technology to make breakfast.
Oh, yeah, why not? When you can do it, why not?
Yeah.
So I'll go here and I'll look at some of this low frequency, and then we'll talk about, I'm gonna go really low here to this really tiny peak, oops, down here at about, I'm gonna guess that that's around 200 Hertz based on this range that I have. And I can type that in too. If I wanna tighten it up even more, I could say 150 to, let's say, 400. So I can move the cursors, or I can type in a range for anything I want to see. Now this is pretty low frequency, and with the low frequency, you're going to have a pretty large wavelength. Using array technologies, you may get a large red dot, something like this, when you look at low frequency and you're trying to figure out what's going on. And what that's telling us is that there's noise in the picture. Would you agree, Steph?
Yeah, that's not super helpful.
No. So again, in the array data analysis software, I have the ability to do something with an add-in that will enhance the spatial resolution for this noise source localization. And so I'm going to go over here and I'm going to enable that. And I'm going to use a different method. In this case, I can click on this, and some people out there might be familiar, if they've used our product in the past, of this INA, which stands for Irregular Near Field Acoustic Holography. So because the microphones on our sound camera are arranged in a non-row and column pattern, more of a
Spiral, right?
Yeah, spiral. That's a good way of putting it. It's not rows and columns, but it's more of a spiral pattern. We can use what's called a holography algorithm to get more information out of that low frequency and really see where things are coming from. I like to use this Bayesian method, which is similar to the holography algorithm, but does some different things in the background to account for different distances that I may be from the object that I'm measuring. So with that said, I'm going to select this and I'm going to recalculate that. And you'll notice that just the frequency will be calculated in that selected band for this method, and we'll see what happens to this red dot. You can see the red dot really changed here, and the noise is coming from a more visible spot, or you can at least discern results from a different moment in time. And I can do that for a larger frequency too. So if we, again, change the time and frequency and I run it again, we'll see what result we get there. And we can see what's happening over that time. So this calculation can take a little bit of time just because it's pretty labor intensive. And as it runs through, it's calculating all those frequencies and seeing where that greatest noise source is coming from. And because we picked such a large frequency band, it's going to just take a couple seconds to give us that result. And it's almost done. Okay. So now we can see that things are more on the bottom of the coffee grinder. And I'll show you another feature here, Steph. So if we are working, let's say we were trying to really zero in on maybe applying an acoustic material or something for this coffee grinder, I could do a group selection. And you can see I've got two different groups here. And if I turn them on, you'll see where I've selected that group. So this one labeled top, I've highlighted the top of this grinder. And if I select bottom, then I have the bottom of this grinder. And if you were watching up here in the FFT, I'm gonna change my limits. And we'll just do to 2200. You can see the red is the total noise contribution. And then this green and red correspond to the top and bottom groups that I have selected here. and you can see based on the area that I have picked what the contribution is of those sources. So it's almost like a source ranking, or
That's kind of
it's not
crazy.
almost, yeah, it's not almost a source ranking. I guess it actually is a source ranking to see top and bottom of the grinder. And so if I wanted to really kind of improve things and make them maybe quieter and apply a material, it maybe looks like that top area would have the bigger effect.
Huh. That's
Yeah.
new.
Yeah, so that's a pretty cool feature. And I can turn those off. Let's see, some other things I can do here. If I'm interested in third octave as opposed to narrowband, I can right click in this display and just say switch to third octave. And then I can do some source localization based on octave bands. I can even look at my group contribution in those octave bands and see where they stack up. And maybe last but not least, with these curves, I can right click and export to the active section. And then over in Navigator, I get my acoustic camera section.
Wow, that was pretty slick.
Yeah. Again, I can do a display and I can bring that in. Yeah. What else should we show here, Steph?
Can you change the scale on the graph?
Oh, yeah. Which graph? Should I change it on this?
That one or the frequency time one. I guess they're all frequency. No, they're not all frequency time. The color map. One of the two.
Okay. All right. So I'm going to say, let's open up another test. So I'm going to say open. And let's pick a different one of these coffee runs. And here we're at a different spot in this coffee process. And so to see what's making noise, let's just kind of randomly pick a time and frequency band. And we'll hit run. And now we are boiling some water. And so you can see that the tea kettle there is what's making some noise. And we can go here, and if we want to maybe look at this scale, we can change that by right-clicking on it and saying options. And I can make the range maybe a little bigger. So maybe I want to go 8 dB. And what this range corresponds to is the center of the acoustic hotspot. And then it's going to show a scale that goes from that maximum down 8 dB. So if I say OK to that, then I get a little bit of a different picture here. And I can move down to a different frequency. Actually, let's move up in frequency for now. And the other thing I'll point out here is when I pick my time and frequency in this color map, this little square here corresponds to those selections. So if I want to pick a shorter time or a shorter box in that color map, I can adjust my time. And if I want to change things on the frequency scale, I just move the cursor there. But the color map will allow me to highlight an event and simultaneously select that time and frequency for the source localization. So again, we have this nice big peak down here. If I slide down there to see what's going on, because that's low frequency, I'm going to turn on that quantification method again, which is also a power method. And I'll hit run. And we will wait patiently for that to process. And we'll see what's going on at that low frequency. And we can see that's on the other side of the tea kettle at that low frequency.
Very cool. Much more useful.
Yeah.
What's the animation stuff? It says step overlap segment.
Yeah, so if I can't do it in the power method. If I had a moving part, and maybe we'll do that really quick too. We'll show that with Pete's arm moving. Let's go to this one. And we'll pick over a larger time. So we'll see where Pete's hand is over time. I'll click run. You can see our coworker's hand is up here at this position. And we'll use that step. We'll say every half second over these 7 seconds we have selected. We'll hit run. And we'll get that first image. And then if I hit these forward and back arrows, I can step through the time. And it will calculate that first one and show me how many are left to go. So we have 26 to calculate. And I'll just go through them as fast as we can. And you can see that for each step I move, his hand moves to a different position in the image along with the source localization.
And once they're all computed, you can just scroll through them really quick, kind of like hand animating it.
Absolutely.
Nice.
But it's pretty cool how I can see both his arm and the noise source move in sync as I step through the data. And again, all these results are saved for me up at the top too. We can go forward and backward on these images. So I could scroll back through and see how his arm is moving as we go. That actually looks pretty cool, I would say.
Yeah, I like it.